and this is quickype. Quickype gives you static types from JSON and from other data, as we'll see. But we're going to focus on JSON first. Let me know if this sounds somewhat familiar. You have to talk to some server, and the server gives you back JSON, but the format is not really documented. And maybe it's documented, but there's no formal schema. And you get the JSON, you parse it, and then you have a dynamic type, and you don't have IDE support for that, so you wish you had a static type for it, so you can't mistype a property. And then 1 week later, the API changes, but you don't know, something breaks, and you have to investigate. Can you raise your hand if you've ever gone through that? Okay, lots of people raising their hands. Thank you so much. I think I can help. In particular, I think quickype can help. I'm just gonna show you an overview of the web interface, and then we're gonna go into detail. So the basic workflow here is you put JSON in on the left, and types come out on the right. So this is very simple JSON. The type is not very interesting. But we're gonna do query hello TypeScripters. And we have a query string. Really nice. Maybe there's also some values attached. Of course, that must be quoted. 1, 2, 3. Great. It's an array of numbers. So that's how it works. JSON left, types right. Now let's look at something a little bit more interesting and complicated. My favorite JSON file is the Pokédex. The Pokédex is a database of Pokemon and all their wonderful characteristics. I'm going to turn that off. And so let's look at what we have here now. We see that. Sorry, I hope this isn't terrible on the audio. We see that on the left, this whole thing is an object that has a property Pokemon, which is an array of Pokemon, and that's what it shows up as here. And this is what the Pokemon have, what we know about them. So they have an ID, which is a number. They have a number, which is a string. Okay. They have a candy count, which is optional. That means that it's not in all of the Pokemon. Some Pokemon don't have a candy count, apparently. They also have weaknesses. Weaknesses is an array of weakness. Note, by the way, that TypeScript knows that the singular of weaknesses is weakness. It's kind of nice. They also have this evolution thing. There's another nice thing here. Namely, we detect that the weaknesses are probably an enumeration value. So we make an enum for you, as you can see here. And also note that this next evolution and previous evolution thing, I guess Pokemon evolve into each other. I don't actually know how it works, I'm just pretending. But we figure out that because it's called next evolution and previous evolution, the thing is probably called evolution. So we make a type that's called evolution. And we don't just do this for fun, by the way. If you think about it as a programmer, types are part of your user interface. You want nice types. Because you want a nice user interface. Ideally, we would like to give you types that you would write yourself if you put the effort in. But luckily, we have computers, and they can do things automatically, and so that's what we try to do for you. So let's write some code. I'm going to go to Visual Studio Code, where I have this nice little program that makes a request to get the Pokédex. And it's going to log the resulting string to std out. Let's run it to see that it actually works. So as you can see, we get the same file out. But wouldn't it be nice if we could take this URL and put it into a file here called pokedex.url. And then just say something like const pokedex equals convert automatically imported dot to pokedex, and it takes a JSON string, which is nice because I have a JSON string, result dot content. And now I have a strongly typed Pokedex. And I get really nice completion on the Pokedex. So what I want to do is, let's write a little program that prints all of the names of the Pokemons that have water as a weakness. So what I want to do is I want to filter the Pokemon. And as you can see here, the callback takes a Pokemon. So I'm going to filter, this is the Pokemon, and the Pokemon has an array of weaknesses. And I'm going to search in the array of weaknesses, index off. As you can see, the search element that it takes is a weakness. And maybe you can remember that weakness was an enum. So I get this really nice code completion here. And this should be larger or equals 0. So if that is in there, then I'm going to keep the Pokemon. And I'm going to loop over Pokemon off this console.log Pokemon.name. Let's run this app. It's not much of an app. And here is the list of the names of all the hydrophobic Pokemon. I'm going to show you something else. Get to check out pets. So it might not be the case that you have one JSON file that encompasses all of the possible responses that your server will give you. Maybe sometimes some properties are missing. In other cases, other properties are missing. So you have like maybe 10 or 20 different JSONs where you can like somewhat safely say, okay, like these are all the possibilities that are going to come up. And so that's what we have here. We have 3 people. If you put these in a directory, QuickType knows that those are to be treated as the same type, but they're like 3 different versions of that type, and it's going to unify all of those. So let's look at those people. We have Mark. This is me. I'm a software engineer, and I can juggle 5 balls. Then there's Daenerys. She's a queen. She has a bunch of titles. She cannot juggle 5 balls, however. Although in her favor, she has 3 pet dragons who are extremely dangerous. So I'm not going to mess with her. No, but maybe the dragons can juggle. I don't know about that. And then there's David. David, by the way, is my co-conspirator in this project. He actually started the whole thing. He is a designer. He also cannot juggle 5 balls, but he has 2 pets. Very close. But then maybe you don't have just one endpoint in your API. Maybe you have a second endpoint in your API. In this case, we also have a pet store. And so the pet store has a name and it has a location, it has a bunch of pets in its inventory. And the pets also have a price, right? So they're not exactly the same data structure, but they're kind of similar. So let's look at the model that is generated from this thing. So we can see here that in the person, the titles and the pets are optional because not all of the people have titles and pets or pets. But the pet data structure is the same except that the price is optional, right? So QuickType has a similarity metric where it figures out, oh, these are probably the same class, and so I'm just gonna put them together. And by the way, I should say also, there's some code at the bottom here that looks weird, but this code actually performs type checking, dynamic type checking for you, namely when you ask it to convert your string to a JSON object, or like to this object, to a person or to a pet store, it makes sure that it does actually conform to this schema. So it'll throw an exception right away if it doesn't, and you're not going to be left hanging in the air wondering what the problem was, right? You'll know right away. I'm going to show you one or two more little things that we can do in the web UI. Another thing that we do is we can often detect when things are supposed to be maps as opposed to just plain objects. So for example, here, this does not look like these are supposed to be property names, right? This is just a map from, I don't know, dates or times or something to something something. And we actually detect this. So I can turn this off. I can turn map detection off, and you'll see what it would look like if we didn't do that, right? But that's not what you want. It's stupid. Let's say you work with this Pokédex, but you're not quite happy with the way that with the types that we generate, because, for example, while you like the way that we make weaknesses into an enum, you don't want egg to be an enum. You want egg to be a string. But we don't want you to just paste this code into your program, because, by the way, another thing we do is we don't just support TypeScript. We also support C#, Go, C++, Java, Swift, Elm, and also, as it turns out, JSON schema. And so if you need 3 of those, you now have to maintain 3 different source files, and whenever something changes, all 3 of them changes, and you don't want to rewrite all of that. So what we suggest is that you generate JSON schema, which we support as an output as well as an input. So what you can do is, let's say I don't like the fact that eggs are an enum, so I'm just gonna take this JSON schema, I'm gonna put it in here. And by the way, of course, all of this works on the command line interface also, obviously. I'm gonna generate TypeScript again, and I get exactly the same output, of course. But still, the egg is this enum, which I don't like. So I'm just gonna modify this and take this away. And now, as you can see, the egg is a string. And this thing on the left, this JSON schema, this is what we propose you should work with if you want to use QuickType in your application, in your build script, wherever in your workflow. Do the schema inference once with as much data as you can. Make sure you get a good schema. Make sure the schema is correct. You still have to look at it to make sure the types are correct. We're not, QuickType is very powerful, but it's not omnipotent or omniscient. And then commit the schema into your repository. It's the source of truth. Maintain this and generate the code from that, client, server code, whatever you need. Oh, that was not what I wanted. I said QuickType also supports other data. In addition to JSON and JSON schema, we also now have experimental GraphQL support. I don't want to do a demo unless you desperately want me to. We think it supports all of GraphQL at this point, although it's experimental a little. It generates nicer types than Apollo. If you've ever used the Apollo types, it basically makes one anonymous type, like for everything. It's just not a nice user interface. The type is technically correct, but it's not nice to work with. We generate types that are nice to work with. If you want to use this, please do, and let us know how it goes. We are super happy to help you with any problems that you have. And this goes, by the way, for anything regarding QuickType. I'm doing the same thing. So as for our future plans, as it regards TypeScript. One of the things that is on our agenda is, and by the way, for this, we would also love to have your feedback on whether you think that this is smart or a stupid idea. Right now, we generate these interfaces, which means that you can just take naked JavaScript objects with no constructors, or like with standard constructors, and just cast them to the types if you're sure that they conform and it'll work. But classes would give us a few nice things that we can't get with these types. For example, we are beholden to the property names that are in the JSON, which are sometimes not what you want, because the JSON, they're not nice like you would write them in TypeScript. Maybe they're really stupid. And also we can do other nice things on classes, like we might be able to do computed properties in the future, which we can't just do if we have an interface. We want to generate type guards for union types. So quickype, if it, for example, if you have an array that contains numbers as well as strings, it will make an array of number or string, right? And the same goes for class types, but you would like to have a type guard where you can check and have a nice function for that. And we would also love a VS Code extension. By the way, if any of you want to work on any of that, that'd be awesome, especially the VS Code extension. Our long-term goal is no untyped data. As I said, the types are your user interface. As a programmer, you want a nice user interface for all your data. So we want to support more data types. We are thinking of supporting XML, which is kind of strongly typed, except that for most programming languages, you don't have nice support in your IDE. We'd like to support CSV, maybe HTML. We need smarter inference. Right now, some of our rules are very, very simple. For example, the heuristics on when we detect enums and maps are very simplistic, but we can do a lot better. We can also, there's a lot of JSON out there where people encode numbers as strings, for example, which is very easy to detect, very easy to fix, but you have to implement it. And we would like to support other IDs as well. For example, Xcode is kind of on the top of the list. So please join us. Quickype is open source. Quickype is written in TypeScript. It's on GitHub. If you have any suggestion or if you find any bugs, please file issues. If you just want to talk, either about features, about collaborating, please join us on Slack. And that's it. Thank you very much.
I should just point out that when you say a hydrophobic Pokemon, that technically also means the Pokemon which have rabies. So since Geodude can't possibly have rabies, probably missing a semicolon or something.
Okay, what is the correct, for future reference, what is the correct term?
No, I think you should probably just choose another example, like the one for rabies.
The pyrophobic ones?
Yeah, because you don't want,
Okay, I apologize.
About rabies and
All right, thank you.
One question, please.
Yes.
I have one question, like how you try to inference the class name. You talk about like inference the class name by the property name.
Yeah.
Next neighbor routine.
Mm-hmm.
Do you also think about like inferencing the class name from the values?
No.
You have like animals, dog, cat.
No, we have not thought about that. I think that would be a much more far-reaching, probably a machine learning problem.
Think about this, the harder problem for generating code is how to choose the right symbol for the name, right?
Mm-hmm.
So, but I think there's not that many different kind of data. On the internet, probably we have already a lot of good names for this kind of problem. Maybe we have a way to automate.
Yeah, I see what you're saying. Yeah, I haven't thought about it from this point of view. We have a few ways of naming stuff, but that's not one of them. But that's an interesting suggestion. Thank you.
How does this play with Swagger?
So Swagger, as far as I know, uses JSON schema to specify types. So right now we don't support Swagger, right? We support JSON schema. So you could take the JSON schema out of the Swagger and put it in. The next step would be for quickype to be able to read Swagger and just generate types, for the types in the Swagger specification. But then what Swagger does on top of that is it's also an API endpoint specification language, which means that you probably want to generate code that does the requests to the server and stuff like that, which right now is a little bit out of the purview of quickype, but if you want to contribute, we'd be happy.
I've got two questions. The first one is, what sort of heuristics do you use to infer that?
So right now, as I said, right now it's very simplistic. Right now we have one heuristic that says if it contains long strings, I think I have a cutoff at like 64 or something, then it's not an enum, so it's out. And then it needs to have at least, I think, 10 values overall, so 10 total strings must be in there, and it must be only strings, right? And the number of unique strings must be less or equal than the square root of the total number, which is just something I pulled out of my behind. If you have better suggestions, I would love to. So one obvious thing is you would want it to be an enum if the keys look like something meaningful, right? If the keys are just random characters, then it's probably not an enum, right? But we don't have heuristics like that yet. But we're looking for contributions.
Can you probably use the camel case because if you add a space in between, probably the other.
Yeah. There's many different conventions that people use when they name their properties and their strings. So
so if you're like if you've got a chessboard and all of the knights are gone, then they'll give you like
yes, of course. If you're missing a case in your data, then we can't infer what the missing case is. Yes. But again, you just generate the schema and you add the missing case, right?
So the second question I guess I had was, do you support any sort of like custom rules like, I definitely want to override and have to do something else? And I guess that's more important if you had an API.
I'm sorry, to override what?
So like, first of all, do you have a sort of like automated API for just consuming JSON data and spitting out these interfaces? And two, if you had such a thing, would you support something like, oh yeah, this is definitely a mess, like allowing the inputter to give you stronger hints and like removing more guesswork out of the information, I guess. Are there methods for that, or is that currently all just fully automated? Everything is right there.
So as far as I understand, your second question is, can you make the property name, can you give it a different property name?
Well,
than,
that too, but also other little things like point out a particular property name as, oh yeah, this is definitely stop guessing.
oh, I see. No, you have to go through the JSON schema to do that. So that is your second question. Your first question was, do we have an API for invoking quickype on your input data and spitting out type definitions? Yes, but it's not very well documented and kind of impromptu. And does that sound familiar? But yeah, yes. There is an API. If you want it, if you want to work with it, we would love to work with you and make it a properly specified one. That's actually one thing that we sometimes collide at, because David does the web UI and I break his API. And so.
Oh, you're asking about what's the API like for importing QuickType as an npm module? Yeah, something to that. Oh, it's super nice now.
Oh, well, there you go.
Oh, it's really nice, yeah. So
is it well documented?
It's non-documented. I am like the living bard of the API. Yeah, so just to answer your question straightforwardly, well, I just broke the entire API yesterday, but yeah, we have a main module. If you just do npm install -d or whatever, install our npm module QuickType. That will give you a QuickType CLI. Actually, can I show on your computer, Mark?
Do you want the?
You just go to your browser.
Yeah.
Oh, yeah. Yeah, just so you guys know, at quickype.io is this web interface. And we've got some helpful links, so we'll just go to GitHub. We don't link to NPM yet. Actually, I suppose that's at the top of our README right here. But if we go to, let's see, source index.ts, so this is the module that you would import if you install via NPM, and we re-export, because we have a pretty complex set of modules that we use internally. I haven't even told Mark this yet, but this module defines our public API. I didn't even know. Yeah, I just learned it too. It's a great feature. So the type of things that you can import from QuickType in your own code are, the main one is this. It's at the bottom, yeah. So at the bottom, there's a function called QuickType, and it takes some options and then an option to whether or not to cache. You can just ignore that. And the options are very straightforward. And you can see it takes a partially defined options value. So all you have to do is basically define language, which can be a string. So you can pass it the string Swift, and then an array of samples. Oh, right here. Yeah, so here's the options type. So you just have to specify some set of these properties, and it will return to you basically an array of strings and error messages. And that's going to be pretty stable. I mean, we will break it, but we'll increment the major version number. But yeah, it's trivial for you to just import QuickType into your own JavaScript or TypeScript project and call it to generate code. Super easy. Yeah.
So this is really cool, and definitely going to use this. Have you thought about applying this to languages and not just like JSON stuff? Like you could apply this to JavaScript, produce TypeScript, or apply Python and produce finite code. You can like Haskell produce signature.
We haven't thought about it much. There are some languages that support generating JSON schema from the types that you already have. So for example, in C#, and also in Java, but I'm not as familiar with Java, but in C#, there's the standard JSON thing is called json.net. And it allows you you can either add annotations or you can just leave them out and it will figure out most of that just based on your types. But one thing you can tell it is, instead of using these types to parse some JSON, just give me the JSON schema that those types represent. And automatically you have a schema and you can feed it into QuickType and you can generate output in any other programming language. So we don't have any plans yet for like parsing Haskell, for example, if that is your question.
If you want to do a proof of concept, if you just make a front end for QuickType that will parse the language you're interested in into a JSON value, then you can QuickType that, or a JSON schema. So that would be a shortcut. I mean, that's one of the things I've been interested in is QuickTyping HTML. So there's a sort of black art of web scraping. Everyone has to do it once in a while. It's so graphy, but I was like, what if we could just generate type of the type that you expect from an HTML document? the route that we would take to accomplish that is you would get some sort of like descriptor of the data you want to extract from HTML, and we would extract JSON value, or JSON schema that goes into that. So if you wanted to do Haskell, for example, actually we saw some work in the PureScript community. They were, oh sure, yeah. So quickype started as a PureScript project. Are any of you guys familiar with PureScript? Sort of like strict Haskell. It's like TypeScript, but the syntax is more Haskell than JavaScript. They have a project which outputs PureScript types as TypeScript interfaces to try to improve PureScript and TypeScript passing values back and forth. So I'm guessing that's what you had in mind, sort of interop between languages.
Yeah, I think like the first like really cool kind of use case would be like in those JavaScript outcomes. Because the inference and the generation is pretty simple. It's for JSON JavaScript.
I've never really seen a code base where you have well-defined types in JavaScript per se.
But that's the thing, like here the types are not super well-defined either. That's, you know, all these super cool heuristics.
Yeah.
But this is just data. JavaScript is code, and code has dynamic behavior, and JavaScript is like weird stuff. One thing you might be able to do is to write an npm module that you can hook into your types. I'm just brainstorming here. That you hook into your types dynamically and say, please observe this type at runtime and infer the schema at the end of my run. I think if I had to do this project, if you told me you have to do this and you have to deliver, this is probably what I would try first. I wouldn't go from the source.
Yeah, we can continue this offline. There's a guy at the University of Mississippi that just did this for Python.
Okay. Yeah, that sounds like a plausible avenue.
I can't wait to like stick this in one of our Rails middleware so that I don't have to deal with the lag.
Oh, yeah, we don't have Ruby yet, so we're really excited to apply this technique that we did with TypeScript, where we do the runtime validation of value. So we have someone working on a Python backend, but Ruby would be next. And yeah, I think it'd be great to you have JSON from an API, you instantiate it with more or less dynamic Ruby value, and you define all the properties. You can get code completion in Sublime Text or whatever your Ruby IDE is. And then you would have a runtime checker that would look for value, and it would tell you at which point, where in the tree of data that value diverges from the expensive type, which is really clear. Adding a new programming language, adding a new target language is probably actually the easiest target for contributors, because it's like a relatively stable API. There's already 7 of them, so you can pretty easily figure out what they do, and our infrastructure actually does a lot for you that you don't have to worry about. Like, it turns out actually one of the most difficult things about producing code for this many different programming languages is just figuring out how to name things, because each programming language has different scoping rules. They have different keywords. There are different cases to consider of when something clashes, and I don't even want to talk about Unicode. Yes, please.
Do you build an AFD of the JSON schema before passing it out to the backend?
Yes, so quickype is actually, in terms of structure, very similar to a portable compiler in that it has a bunch of front ends that translate to a portable intermediate representation of types, which is a type graph in our case. And we do a few transformation on this type graph, like for example, detecting when classes are supposed to be the same and collapse them, which is actually a pretty non-trivial operation if you think about it in terms of what has to happen in the graph. And also the enum inference and stuff. And then all the backends generate code from that type graph. All right, seems like there's no more questions. So thank you again very much.